Okay, so this is the Chapter 8 Modified Notes, and what I'll do is go through this, and you can follow along. So you've already actually done some of this in your some of your previous labs. So basically, on the limiting reagent, theoretical yield, actual yield, percent yield, we've actually already done some of these. But we'll do some additional practice problems since you'll have a few of these on your test. So let's look at calculating the theoretical yield and limiting reagent when we're given moles of the reactants. And I know this isn't like super clear on the video, but you should have this sheet already printed out. So it says here, if we have 1.8 moles of titanium and 3.2 moles of chlorine, we're going to calculate the limiting reagent and theoretical yield. Get that focus better. All right, I'm just playing with this, trying to get it to focus better. I'll try to write big. So on step 1, what we're going to do is write the ratios. And so that's from the original equation here. So it says I have 1 mole of titanium. So here I'm going to do 1 mole of titanium. And it's a ratio. So 1 mole of titanium for every 1 mole of titanium, the product here, the titanium chloride. So I'm going to do 1 mole of that. And then the other is I have 2 moles of this chlorine gas, and it's hard to see, but that's a Cl2. So I have 2 moles of chlorine for every 1 mole of product. And then we're ready for step 2, and this is like what we did in lab before. So I'm given 1.8 moles of titanium, so I'm going to write what I'm given, 1.8 moles of titanium over 1. And down, or over here, I'm given 3.2 moles of chlorine gas. So 3.2 moles of the Cl2 over 1. So I'm trying to go from moles of titanium to moles of this titanium chloride. So this second step is just the ratio step. So I go back up here. I want to get rid of moles of titanium, so let me put that down here. And I want moles of my product. And so I just look at the ratio up here. For every 1 mole of titanium, I have 1 mole of product. So it's a 1-to-1 ratio. On this step, again, this second step is the ratio step. I want to get rid of moles of chlorine, and I want moles of my product. So I go back up here, and it says for every 2 moles of chlorine, I have 1 mole of product. So it's a 2-to-1 ratio. So my moles, titanium cancel, those cancel. And then I just multiply. So 1.8 times 1 divided by 1 is still 1.8. um, of titanium chloride. And then down here, you would go 3.2 times 1 divided by 2, and I think you'll get, and you can always pause this. I've actually already done these calculations, but if you need to pause to do them, you can. Okay, so this is like what it was in the lab. So we're going to compare our end answers here. So I have 1.8 and 1.6. And if you remember from lab, we want the smaller of the two numbers, because this is like the example about the cracker, the piece of cheese, and the piece of ham. So our theoretical, so the smaller number is the theoretical yield. So the theoretical yield is 1.6 moles of our product. And then you might remember, if this is the theoretical yield, then we need to see what reactant created that theoretical yield. And in this case, the reactant was chlorine. So our limiting reagent is chlorine. And so just as a little reminder, that we did in lab, making the little snackers. Let's say these are crackers. This is ham. And this is cheese down here. So I have 4 crackers, 3 slices of ham, and 2 pieces of cheese. So if a snacker, if that product means 1 cracker with a piece of ham with a piece of cheese on top, based on my ingredients, how many snackers can I make? So I could only make a total of 2, because I only have 2 slices of cheese. So in this case, the 2, that's the fewest number I can make. So the 2 would be the theoretical yield. And then what am I limited by? I'm limited by the amount of cheese. So just like down here, the 1.6, that's our theoretical yield. That's like up here, only being able to make 2 snackers. And why is that the theoretical yield? Well, we're limited by one of our ingredients. And what ingredient is that? Up here was the cheese, and down here, to get the ingredient, we go back to the beginning, and it's chlorine. So on the next page, here's another example. This time we're dealing with aluminum and chlorine gas. So on step 1, this would be the ratio step. So looking back up here, I have 2 moles of aluminum for every 2 moles of aluminum chloride. And then I have 3 moles of chlorine gas, so it's 3 moles of Cl2 for every 2 moles. I'm sorry, I don't know why this isn't focusing very well. For every 2 moles of product. I forgot to add the word moles in there. So to set this up, we do the same thing. We start with our we start with what we're given in the problem. We have 0.552 moles of aluminum. And in the original problem, it says we have 0.887 moles of chlorine gas. I don't know if you can hear that noise. Those are some cats trying to get in the room. Like my cats, not just random cats. So here, the second step is the ratio step. So we want to get rid of moles of aluminum, and we want moles of aluminum chloride. Down here, we want to get rid of moles of chlorine, and we want moles of aluminum chloride. So our ratio between aluminum and aluminum chloride is a 2 to 2 ratio. And down here, the ratio between chlorine and aluminum chloride, it's a 3 to 2 ratio. Let's see, I have already worked these out. So when you do the math, and again, you could pause and actually do the math and then compare. But I got 0.552 moles of aluminum chloride. And for this one, I got 0.591 moles of aluminum chloride. So again, to find the theoretical yield, the theoretical yield is the smaller of the two. So 0.55 is smaller than 0.59. So this is our theoretical yield. Bella, hang on, I'll be done. And the limiting reagent, so it's what we're limited by. What ingredient are we limited by? So we go back to the beginning, and it's aluminum. So aluminum is our limiting reagent. On section 2, we're doing the same thing, except this time, rather than being given moles, we're going to be given grams, the masses. But we're going to have, the steps are going to be very similar, but we'll have one additional step in there. So on step 1, I'm still going to do ratios. So I have 2 moles of sodium chloride for every 2 moles, 2 moles of sodium for every 2 moles of sodium chloride. So it's a 2 to 2 ratio. And then for my chlorine, I have 1 mole of chlorine for every 2 moles of product. And then down here, we go with what we're given. Bella, stop it! 53.2 grams of sodium. I didn't leave a lot of room here. Let's see. And 65.8 grams of chlorine. So we want to get rid of grams of sodium, so I'm going to put that on bottom. And we want moles of sodium. And down here, we want to get rid of grams of chlorine, and we want moles of chlorine. Okay, so to find grams of sodium, we look on the periodic table to find the mass number. And so on the periodic table, the mass number of sodium rounded is 23. And we look on the periodic table to find the mass number of chlorine, which is 35. But you see there's a 2 there, so we have 2 of them. So it would be our 35 plus 35, so a total of 70. So this is a step that's different from the previous 2. But then our third step is going to be the ratio step. Because what we're going to do is we want to get rid of moles of sodium, and we want moles of sodium chloride. And we want to get rid of moles of chlorine, and we want moles of sodium chloride, our product. So it's the ratio. So on sodium, it's a 2 to 2 ratio. So a 2 to 2 ratio. And with chlorine, it's a 1 to 2 ratio. So a 1 to 2 ratio. And then the last step, we want to get rid of moles of NaCl. And we want grams of NaCl. So in 1 mole. So to get grams of sodium chloride, this is like finding the formula weight. So we look up the mass of sodium and we look up the mass of chlorine and then add them together. So sodium's mass is 23 and chlorine's mass is 35. Again, those numbers are just from the periodic table. And if we add 23 and 35 together, we'll get 58. And so it's still 58 down here. And then again, you can pause here if you want to do the calculations on your calculator. But like I said, I've already worked these out, so I'll go ahead and write down what I got. For this one, I got 134 grams of NaCl. And for this one, I got 109 grams of NaCl. So the two numbers that we're comparing are the 134 and the 109. So 109 is the smaller number. So 109 grams will be our theoretical yield. And then what ingredient is associated with this theoretical yield? Chlorine. Oh, and in case you're wondering, I've played around with this camera. I don't have a, in the software, you can't like flip the image, so I've had to flip the camera, and that's why it's kind of at a crazy angle. Okay, I think there are a couple more that are like that one. Oh, no, there's one more question. there's a question down here at the bottom. It was asking us to calculate the percent yield. So back on the first page, this is like what we did in the aspirin lab. So the percent yield, let me get that to focus. We're going to take our actual yield divided by the theoretical yield times 100 to get a percentage. So on this one, it was 80. So our actual yield is 86.4 grams divided by, and we're going to divide this by the theoretical yield, which was 109. Times 100, and this will give us a percentage, and when I did my calculation, I got 79.2%. And if you want, like, you could pause this and work these last two problems if you wanted, and then go back and check. But I'll just go through the steps again. So again, with step one is our ratio. This one is a little unique because we have two reactants and two products. So let's look at nitrogen monoxide first. So we have 2 moles of NO. And we'll compare that to the products where we have 2 moles of NH3 and 2 moles of H2O. So it's a 2 to 2 to 2 ratio. And we'll compare that with our other reactant, which is the hydrogen gas, and I have 5 of those, so 5 moles of H2. And again, the ratios on with the products are 2 moles of NH3 and 2 moles of H2O. So this is another one where we're starting with grams. So we're going to go from grams to moles, and then moles of, say, NO to moles of NH3, and then to grams of NH3. Because our question says we want to find the theoretical yield of NH3. So I'll start with, I'm given 45.8 grams of NO, and I'm given 12.4 grams of hydrogen gas, so in the second step, I want to go from grams to moles. So I want to get rid of grams of NO, and I want to get rid of grams of H2, and I want moles of NO, and I want moles of H2. So in 1 mole of NO, to calculate grams, what you'll do is you'll go to your periodic table, and I think the mass of nitrogen, I believe, is 28. No, it's not. What is nitrogen? Is it 14? Yes, I think it's 14. I think the mass of nitrogen is 14 and the mass of oxygen is 16, because that will add up to give us 30. And then the mass of hydrogen is 1, but I have two of them. So 1 times 2 is 2. This third step is our ratio step. So I want to get rid of moles of NO, and I want moles of NH3. How do I know that? Because up here it says we're trying to find the theoretical yield of NH3. And down here I want to get rid of moles of H2, and I want moles of NH3. So what are my ratios? Well, here this is a 2 to 2 ratio. And with my hydrogen, it's a 5 to 2 ratio. So now I have moles of NH3, and my last step, I want to convert that to grams of NH3. So I want to get rid of moles of NH3. And I want grams of NH3. So to find our formula weight of NH3, we're going to look up the mass of nitrogen, which I believe is 14, and the mass of hydrogen, which is 1, and we have 3 of them, so that would be 1 times 3 is 3. So 14 plus 3 is 17. And then if you want to pause and do the calculations, when I did mine, staying with significant figures, this one rounded to 26.0, and I'm putting that 0 there because I started with 45.8, which is 3 significant figures. And then on this one, I got 42.2. So in comparing these numbers, 26 and 42, 26 is the smaller number, so 26 will be my theoretical yield. And what ingredient is associated with this 26? So I go back to the beginning, and it's NO. Okay, and on this last one, oh, I heard this joke the other day. What did the duck say to the bartender? Put it on my bill. On ratios, on this one, so we have 1 mole of Fe2O3. Whoops, I didn't mean to underline. Pretend I didn't underline that. And over here we have 2 moles of Fe and 3 moles of CO2. And then 3 moles of CO. Remember, this isn't division. I just accidentally, we're just going to pretend that that line is not there. And then the ratio is 2 moles of Fe and 3 moles of CO2. I really just wish I did a better job focusing. So down here, we're given 185 print. Let me see if turning this off will make a difference. No, maybe that was a little bit better. 185 grams of our iron oxide and 95.3 grams of CO. So we want to get rid of grams of iron oxide, and we want moles of iron oxide. By the way, that would be iron 3 oxide if you did the correct nomenclature. And then down here we want to get rid of grams of carbon monoxide, and we want moles of carbon monoxide. So to get grams of iron oxide, you're going to look up the mass number of iron off the periodic table and multiply it by 2 because there are 2 irons. And then you want to, oops. And then you want to add to that the mass of oxygen, which is 16 times 3. So you'll look up, I don't have a periodic table. What if I do? I have the book right here. Let's see. Iron is 56. So you go 56 times 2 plus the oxygen, 16 times 3. And you should get 160. And down here, you'll look up the mass of carbon, which is 12, and the mass of oxygen, which is 16, and they're just one of them, one of each, so that would be 28. The third step is the ratio step, so I want to get rid of moles of Fe2O3, and I want moles. Let's see, I'm going to go back in the original problem, and we're trying to find the theoretical yield of iron. So I want moles of iron. And down here, I want to get rid of moles of CO, and I want moles of iron. So on my ratios, I have 1, 2, so I have a 1 to 2 ratio. And with my CO, I have a 3 to 2 ratio. And then the last step, we're getting rid of moles of iron, and we want grams of iron. So to find grams of iron, you just look on the periodic table to find the mass number of iron, which rounded is 56. And then you're ready to do the math, which I've already done, but I got, for this one on top, I had 130 grams of iron. And for this, 127 grams of iron. So our numbers that we're comparing, the 130 and the 127. So 127 is the smaller of the numbers. So our theoretical yield is 127 grams of iron. And what ingredient was associated with that? CO. So my limiting reagent is CO. And then lastly, it is asking us to calculate the percent yield, which is our actual yield divided by theoretical yield times 100. So the actual yield is 87.4 grams. And we're going to divide that by our theoretical yield, which is 127 times 100. And I got 69%. There, so there's that page if you need to see everything in focus. Here was page 2 in focus. And there was page 1 in focus. So that concludes the chapter 8 modified notes.